So there's a few things that we need to really pay attention to that JSON can do for storing data of really flexible and interesting types. So first of all, JSON can store different data types for the same feature from observation to observation in the data. So here we have two people in our political data. For the first case, we asked them to rate the Republican and the Democrat. How do you feel about the Republican? They said awful. How do you feel about the Democrat? Pretty good. And then this person, how do you rate the Republican? 28. And the Democrat, 52. Yeah, so something like that. The point is we can store strings in one observation and then numbers in the next very easily in JSON, and that's going to be a problem for data frames, in which we're going to convert JSONs to in just a few minutes here. The other thing that JSON can do is it can store different features or different variables for different observations here. So the first observation in the data has 4 features, and the second only has 3. This one is missing the vote, right? Maybe this person didn't turn out to vote, and so there was no point in recording who they voted for. So vote doesn't even appear here. This one has all the features from the first case, but with a comment, right? Like this person felt the need to also give a comment. So in this case, this is data with missingness in it. JSON handles missingness by just not reporting the data points that are missing. It's a really elegant solution. There's no need to type out NA or anything like that. Here's an example. This is some fake customer data that we use as an example on the notebook for this week. Just take a look at the different features that are stored in this dictionary just for a second. And then let's go over the tree-like structure that this sort of thing comes from. All right, so just take a look at that. Pause the video if you'd like to have more time. It looks like this. So we have these top-level features, and then we have some features that are nested within the top-level features. We even have a couple features that are nested in a third level. So at that top level, we have ID, name, username, email address, phone, website, and company. Now, for all but 2 of them, it's just equal to some data point, whether it's a string or numbers or what. But address is equal to a dictionary. And in that dictionary for address are yet more features. So we have street, suite, city, zip code, and geo. And geo is itself equal to another dictionary where we have lat and long. Okay, so what this shape is in JSON is a nested and tree-like shape. Now, that's cool. A lot of real-world data has that shape. It's a logical way to think about data. Problem is, that's not tabular. That'll never fit into a flat file or rectangular file. Now, most statistical or analytical tools, machine learning and so on, they need flat and tabular data. So CSV is good because it loads directly into that shape, but JSON, which can store data structures that are awkward or impossible for CSV, such as nesting, it can be converted to tabular, but in so doing, we lose information. There's some valuable information there in that nesting. It's good to know that street is nested within address. There's not a natural way in a tabular data set to express that kind of nesting. And so we can take the 15 distinct data points that are in that one observation that we saw, and we can put them into 15 columns in the data frame. But again, we lose the information on nesting. Now, the other interesting data structure that exists in JSONs is metadata. So, excuse me. Metadata is data that provides information about other data. So we might have information about the data as a whole, such as when were the data last accessed, what's the stable URL for accessing these data, who's the author of the data, what's a copyright, stuff like that, prior to actually getting to the different records in the data. Now, we can, just like with nesting, we can convert a JSON structure with metadata to a data frame. However, again, we will lose information, right? We either have to remove the metadata entirely or do something inefficient, which is store the metadata in a way that is constant down an entire column and take up more memory that way. So it's ideal to convert to a data frame. This is what a tree looks like when there is metadata. Notice we have a really nice JSON file down here, but we have this whole extra branch, right? So this could be who's the author, and then here's all the data. And just to show you a real-world example of metadata, this is the Reddit API that is going to show us the top 25 posts at the moment on their popular page. And so when I go to JSON, this is how it looks like in their browser. Kind equal listing. This is metadata, right? So it's telling us what kind of data are you pulling from our API right now. This is a listing of posts. And then if I click this arrow, it's going to expand all the branches that are nested within data. Okay, so under data we have mod hash, dist, I don't know what all of these things mean, but after, null, and here we have children, which has more nesting. Okay, so these four are again a second level of metadata. Now under children, now we get to the records. Okay, so this is the current top post on Reddit, the next one, and the next one, and the next one, and here's yet a third level of metadata, and then we finally get to the data, and now we can see things. My boyfriend and I, something about belly rubs. I don't know. It's awe, so it's not a dirty post. It's probably about like a cute dog. So you can go and check that out. Anyway, this is what real world JSON data looks like.